Okay, for our fourth example for this topic, we have here a rectangular wood panel and formed by gluing together two boards along the 30-degree seam as shown. Yan. So we have here a 30-degree seam and yan siya ginlu. Determine the largest axial force P that can be carried safely by the panel if the working stress for the wood is 1,120 psi and the normal and shear stress in the glue are limited to 700 pounds per square inch and 450 pounds per square inch. Okay. So, paano to ngayon, ano? So, sabi niya, meron ka daw wooden panel dito. And ginlu mo siya dito sa may seam na ito or sa may biyak na ito. Sa hati na yan. At 30 degrees with respect to the horizontal plane. So, naka-incline lang ng konti dito yung itsura niya. Nakatagilid lang. Pero, this is a rectangular wooden panel. And meron siyang 30 degrees in line with the horizontal plane. Yan. So, the dimensions of the cross-sectional area of the wooden panel is or are given as shown. So, meron ka ditong 1 inch na lapad and 4 inch na length ng cross-sectional area. And loads are applied as shown. Ayan. Meron kang tensile force P. And ano ba itong given ng working stress for the wood? So, obviously, working stress. No? Sabi nga niya, working stress. And yung normal and shear stress in the glue. Ayan. So, ano yung pinagkaiba nun sa working stress? Bakit daw meron pang normal and shear stresses na nag-a-act dun sa glue na may values na 700 and 450 psi. Okay. So, proceed tayo sa solution. So, the most convenient method for analyzing this type of design problem is by calculating the largest safe value of P or force P. Yan. Na magsasatisfy for each of the three design criteria. So, diniscuss na natin yung design criteria na yun. And the smallest from the three values, kagaya nga ng sinasabi ko paulit-ulit, is the largest safe value of P for the panel. Hindi laging greater ang pinipili. Ano? So, pagdating sa pagde-design, iba. Yan. Mas maliit ang hinahanap natin. So, ayan. So, to solve for or to design for working stress in the wood, we have here the value of P for which the wood would reach its working stress. Yan. So, by using our formula, stress equal to P over A or force over the cross-sectional area, gagamitin muna natin dito yung working stress ni wood or para kay wood na 1,120 psi. And rearrange natin to or tinranspose lang natin tong equation natin ni stress into P equal to the working stress multiplied by A. Yan. Sinosolve natin yung working stress para kay wood. Therefore, ang gagamitin natin is yung tawag dito, yung force para kay wood depending on the working stress given in the problem. So, ang gagamitin natin dito is obviously yung working stress na binigay dun sa problem. Therefore, we have here the unknown value of force P in pounds per square inch and equal to 1,120 psi multiplied by the cross-sectional area of the wood na 4 inch times or by 1 inch. And this is equal to 4,480 pounds. So, ito, yan. Ang kinonsider dito is yung initial cross-sectional area. Kino-consider niya na itong load P na ito is dito mag-a-act sa cross-sectional area na to. Yan. Babatakin niya yan. Paghihiwalayin niya yan. Yan. And this is acting on the cross-sectional area. considering that the wood has a working stress of 1,120 psi. Ayan. Pero hindi pa dun tapos yung problem natin. Since kino-consider din natin ang normal and shear stress dun sa seam or dun sa pinagdidikitan nila nung dalawang portion ng ating wood pagdating dito sa mga ganitong problem. Kasi kung makikita nyo, ito yung explanation dyan. The actual force P that would cause the normal stress in the glue, yan, to equal its maximum allowable value is computed as follows. And ito yun. Yan. The cross-sectional area of the wood, which can be considered as yan, the initial area of A or the initial area A sub O, yan, if taken from its original surface, would simply be equal to, ayan, ito nga yun, yung 4 by 1 or simply 4 square inch. And yung sinasabi ko kanina, ito yung computation na natin, dire-diretso na to. Hindi lang ito Okay. But in this case, ayan, the cross-sectional area that will be used is the area from which the wood is glued. Ayan, kung saan sila nakaglue. Kung i-imagine niyo mabuti, i-visualize niyo mabuti. Okay, ano? So, sabi niya, ganyan, di ba? Ay, pumaling. Ang hirap talaga mag-drawing sa, touch pen ba tawag dito? Yan. Ang kinuha niyang area nung una is yung area nung pinaka cross-section ng wood kapag biniyak mo siya sa gitna. Pero, ginlue siya, kung makikita nyo, dito sa may seam. Yan. Dun sa may biyak nilang dalawa. And sinasabi dito na itong area na to is the initial cross-sectional area pa lang. So, kung ang i-consider mo is yung normal and shear stress acting in the glue, ang gagamitin mong area doon to solve for the value of the load P na hinahanap natin is yung area kung saan nag-aaktong itong normal and shear stress. And yung area na yon is nandito sa may seam ng glue. Ito. And to solve for that, kailangan nating i-consider yung initial cross-sectional area ni wood and yung angle na to. Ayan. So, sabi ko nga dito, in this case, the cross-sectional area that will be used, yan, is the form or the area from which the wood is glued. Yan. The slanted surface of the wood with an angle of 30 degrees with respect to the horizontal axis. Ayan, in English ko lang sinabi ko kanina. And therefore, by using trigonometric functions to solve for the area of the glued surface, we use cosine of theta equal to adjacent over hypotenuse. Okay. So, kung titignan nyo mabuti, ito, gumawa ako dito ng isa pang figure. Itong initial area natin na makikita nyo sa taas, ayan, when you look at the front face of the wood, and yung ating area na gagamitin natin, considering normal and shearing stress in the glued portion of the wood, is slanted like this or can be visualized like this. Ayan. And therefore, kapag pinroject mo tong initial area na to, dito sa may horizontal axis na makikita mo, yan, in line with the 30-degree angle, ito rin si initial area A sub O. And ito si area A. Sabihin natin ito yung area A. Or yung area dun sa may glued portion. And therefore, we can use SOHCAHTOA. And in this case, we use cosine of theta, which is adjacent over hypotenuse. Yan. Where yung A nga and yung A sub O, ito nilagay ko, cross-sectional area of the glued surface and yung A sub O or yung initial cross-sectional area of the wood. So, yung A is the hypotenuse and yung A sub O is yung ating adjacent side. Since pinroject ko siya dito sa ating horizontal axis. Ayan. Therefore, we have here cosine of 30 degrees equal to yung ating adjacent side na 4 square inch over yung ating hypotenuse or yung unknown value ng A at the glued portion of the wood. And by transposition or rearranging the equation, we have area A equal to 4 square inch over cosine of 30 degrees. And this is equal to 4.619 square inch. Okay, ni-round off ko ulit into 3 decimal places. And by taking the upper portion of the section, the internal forces in the glued section can now be analyzed. So, ito na yung free body diagram natin. So, linawin lang natin, alisin natin yung iba. Para mas makita. Okay. So, lagay po lang muna natin dito yung area A. Yan. So, ang ginawa dito sa free body diagram is yung direction netong force P acting on the wood or acting along the wooden panel. In-extend siya dito. Yan, in-extend siya all along the span of the wood. Tapos, nag-draw ng perpendicular line dito sa may glued surface. Ano ba itong perpendicular line na ito? Ito yung ating normal force. And itong normal force na to, yung magbibigay ng normal stress na given dito sa ating problem. Okay? Doon sa may perpendicular line na yun, mag-draw ka ngayon ng parallel line. Yan, in line with the glued portion of the wood or along the inclination of the wood with respect to the horizontal plane. And etong parallel line na to or adjacent line na to is yung shearing force naman na tinatawag. And ito yung magbibigay ng shearing stress na sinasabi doon sa problem. And from this triangle, i-analyze mong mabuti nasaan yung 30 degrees dito. Okay? In that way, pwede mong isolve using trigonometric functions ulit yung value ng force P and shearing force V using P over A din. Yan. So, ito, kung ititignan natin mabuti, we have this corner of the triangle formed as the 30-degree angle. So, tuloy. Note that the normal force P and shear force V acting at the glued section of the wood are the components of the tensile force acting parallel to the cross-section of the wood. So, itong normal and shearing force na to is yung components nitong force P. Itong force P na to, yung in-extend mo. Yung nag-act mismo dun sa wood. Okay, and makikita mo siya pag pinaghiwalay mo yung dalawang portion ng wooden panel na yan. And in this case, or on our problem, we took the upper portion of the wood. Pero kahit naman yung lower portion ng kinuha mo, wala namang problema dun. Okay. Basta susundin mo yung step kung paano mag-construct ng free body diagram sa ganitong problem. And then we proceed to solving for the normal and shear stress, yan, caused by the components of the shearing force P acting at the glued section. And we are using our formula, stress equal to P over A. In this case, we have 2. Yan, para kay normal, so we used sigma P, yan, equal to P over A, yan, and tau V, since ang symbol ni shearing is tau. Yan. And yung symbol para naman kay shear force is V, equal to V over A. So, ang known lang natin dito is yung cross-sectional area A na sinolve natin kanina. Okay. And yung values nitong normal and shear stress. Ang hinahanap natin dito is yung maximum allowable load P. Okay. So, for normal stress, we have normal stress equal to P cosine of 30 degrees over yung cross-sectional area ng glued portion na sinolve natin kanina na 4.619 square inch. Okay, bakit siya naging P cosine of 30? Kasi kung titignan mo, yan, gawa tayo ng magandang triangle. Kunyari, maganda. Yan. Titignan mo, okay, ito yung ating normal force P, ito yung shearing force V, ito yung ating angle na 30 degrees. Okay. Ay, baliktad pala, no? Yan, yun lang yung problema nyo. Mahirap kasing titigan sa laptop, hindi ko kasi, may tagilid yung laptop. Joke lang. Okay. So, this is V and this is P. So, for normal stress, we used P cosine of 30 degrees. Ayan. So, tignan nyo lang mabuti. Ayan. P is adjacent with respect to our angle of 30 degrees to the triangle formed by these two forces in the glued portion of the wood. Yan. Therefore, we have this formula formed in our equation. P cosine of 30 degrees over P 4.619 square inch. And the normal stress given in the problem is equal to 700 pounds per square inch. So, wala na tayong problema dito. Input mo na lang sa calculator. And tinranspose ulit natin yung 4.619 square inch sa kabila. No? So, sa ganun, para pag nag-shift solve, mabilis yung calculator. Okay. So, inputting this in your calculator and by pressing shift solve, we get the value of P equal to 3,733.33 pounds. So, dalawa na yung nakuha nating value ng P. Yung isa, sa working stress ni wood. Yung pangalawa, sa normal stress acting on the glued portion of the wood. And yung pangatlo, yung para naman kay shearing stress. No? So, para kay shear stress, ganun lang din yung gagawin natin. So, si shearing force, P, or V, I mean, is equal to P sine of 30 degrees. Okay. Yan. So, P ang nilagay natin since si normal and shearing force, P, or V, acting at the glued portion of the wood, are components of our tensile force, P, as shown in the figure, kanina sa taas. Okay. So, balik natin. So, itong force P na to, meron siyang components na makikita mo dito sa glued portion of the wood. And they are the normal and shearing force na pinakita naman natin dito sa free body diagram. Okay. Kaya P sin 30 yung nakalagay doon. So, equal to kay V. Ayan. And this is equal to P. Or pwede mo ring sabihin ng N, para naman kay normal. So, kung saan ka masaya. Ayan. So, such that the shearing stress at the glued portion is equal to 450 pounds per square inch. And ganun lang din sa kanina. Tinranspose lang ulit and in-input sa calculator and pressing shift solve. Ayan. So, sa mga di marunong mag-shift solve, ayan, hanapin nyo lang sa calculator yan, shift plus solve, automatically, lalabas yung unknown value ng P. And syempre, i-replace nyo sa calculator nyo yung P as X. So, alpha X. Ayan. So, Lagyan ko lang kayo ng sample kung paano i-input sa calculator to. Baka may hindi pa nakakaalam, ano. So, pwede nyo i-input sa calculator to like this, ano. 450, yan, times 4.619 equal to alpha x sine of 30. So, itong x na to, press nyo lang si alpha. Yan. Plus, hanapin nyo yung pinaka-button sa calculator na may makikita kayong pula na letter X and lalabas na tong X na ito. Yan. And i-press nyo itong shift plus solve. And magtatanong yan, solve for X equals, nakalagay na ganun. Pindutin nyo lang yung equal sign. Yan. So, lalabas itong sagot na ito. Try nyo rin dun sa kabila and dun din sa kanina. Okay. So, to choose the correct answer, compare the three solutions above. Yan. It can be seen that the largest safe action load that can be safely applied is governed by the normal stress in the glue. Yan. Its value being 3733.33 pounds. So, sinusunod pa rin natin yung design concepts pagdating dito sa strength of materials. So, in each or in every types of problems or design problems. So, yung pinakamaliit pa rin yung kinuha natin. So, recall lang natin yung nakuha natin. Sa shearing stress, we have 4,156.92. Sa normal stress, 3,733.33. And yung based dun sa working stress ng wood, or in the wood, we have 4,480 pounds. So, hindi natin pwedeng piliin yung base dun sa working stress in the wood and dun sa shearing. Kasi, magfe-fail siya dito kay normal. Okay. Pag ganun ang pinili mo. So, ang kinuha natin dito is yung pinakamaliit. So, paulit-ulit ko lang sinasabi. And that's it for this problem.